What is the role of life cycle assessment in metallurgical engineering and how it can drive sustainable practices in the industry? Life cycle assessment is a key tool for identifying sustainability gaps in metallurgy. It identifies the stages where sustainability can be improved, making it essential for a more eco-friendly industry. It evaluates the environmental impact of the product and processes across their life cycle, from extraction and processing to usage and disposal. Metallurgical industry is a resource-intensive and a major contributor to environmental issues, including carbon emissions and waste production. Through life cycle assessment, it can help pinpoint areas for improvement and find ways to reduce environmental impact. But life cycle assessment integration faces challenges like data gaps, complex methodologies, inconsistent standards, and high cost, particularly for small enterprises. One major issue is the lack of comprehensive data, especially for emerging technologies or areas with limited research. Incomplete data weakens the effectiveness of LCA. Inconsistent LCA standards make it hard to compare results from different studies, leading to confusion and limited applicability. Another key challenge is the inaccessibility of LCA tools and knowledge. Conducting LCA requires specialized knowledge and resources, which are often inaccessible to small businesses and student researchers, which limits their ability to evaluate and adapt sustainable practices effectively. To address these challenges, I propose a solution: the creation of an LCA resource hub and peer network. This hub would be a collaborative platform for students and small businesses to access LCA resources, share knowledge, and support each other's projects. For step 1, build a team. The first step is to build a team of students from different disciplines, including metallurgy, environmental science, and engineering. Collaboration with faculty members will provide the necessary expertise and mentorship to guide the initiative. Step 2. Gather and share resources. Next, gather LCA-related materials, including case studies, software tutorials, and open source guides. This information will be shared through a digital platform, either a website or a social media group, making it accessible to a broader audience. Step 3. Host workshops. Conduct workshops and training sessions to introduce LCA basics and apply them to real-world problems, such as campus recycling systems. Step 4. Collaborate locally. Collaborate with small businesses or organizations to conduct LCAs for their processes, providing hands-on learning while benefiting the community. The proposed solutions will provide several benefits, such as enhancing students' LCA skills, give them valuable practical experience, and promote sustainability in the community. Most importantly, it will help build a culture of sustainability in the next generation of engineers. By understanding LCA, we can focus on resource efficiency and reduce waste. LCA also serve as a guide for making sustainable designs and operational decisions. Moreover, it ensures compliance with environmental regulations and bolster the industry efforts to combat climate change, aligning metallurgy with global sustainability goals. One of our expected results is that students will develop critical skills in LCA, making them more prepared for careers in sustainable engineering. This hands-on experience will be crucial as they enter the workforce. Another expected result is that local businesses will benefit from the sustainable insights, helping them reduce their environmental footprint while also building partnership with students, creating a stronger community. This will also inspire more people to prioritize LCA in metallurgical engineering, paving the way for broader sustainability adoption. This could lead to a wider adoption of LCA in metallurgical industry, benefiting the environment. The Resource Hub can evolve into a global platform, connecting students, researchers, and industry to scale sustainable practices worldwide. By expanding the hub's reach, we could scale sustainable practices worldwide and accelerate the transition to greater metallurgy. Life cycle assessment is a critical tool for evaluating the environmental impacts of metallurgical processes. However, challenges like data gaps, accessibility, and inconsistent standards limit its full potential. By creating collaborative student-driven initiatives like an LCA resource hub, we can bridge these gaps. Combining education with practical application not only fosters sustainability but also drives tangible improvements in both industry, practices, and community impact. Now, I invite you to be part of this change. Whether you're a student or a professional, you can contribute to making metallurgical engineering more sustainable through the power of life cycle assessment. To leave you with a thought, remember the words of Robert Swan. The greatest threat to our planet is the belief that someone else will save it. The responsibility to create a sustainable future lies with each of us. So, let's act now.